later if you need it. Okay, so this is the basic structure of the smart contract, the license. Then we need to specify the Solidity compiler version. To do that, we need to type pragma solidity, and then the version that we want to use. So I will put 0.8.0, and then the semicolon. Any questions so far? Someone is lost? Don't be shy. I'm really happy to answer your question, also to go to your place if you are struggling with something. Yeah. Wait, I didn't hear you. I know that your volume is really quiet. Yeah. This would be the smart contract. Yeah, so we are writing a smart contract right now. Yeah. And then to write the contract, then we need to create the contract object. So we just need to put the keyword contract and then the name of our contract. I will call it DeKUT, like that. Then we open the curly braces, and then all the logic of the smart contract will be inside this object. So inside the contracts, we can find like a lot of different things. Events, state variables, functions, and all these things, but just to help you to get started writing your first smart contract today, I will make something really simple that will allow you to understand a lot of concepts. So our smart contract, will have something that is called a state variable. This is like in JavaScript when we have methods and properties. So yeah, the state variable will just be a variable that we are going to change with the functions, and then we'll have the functions here, and then a constructor. Who don't know what is a constructor? Okay, a constructor is basically a function that can be called only once when you initialize the contract, or in this case when we are talking about the smart contracts, when you deploy a contract to the blockchain, the constructor can be used or can be called only in the deployment. After you deploy the contract, the constructor, let's say, kind of disappear. You can never use the constructor, so you will see that in the example today. So yeah, the constructor is only called when we deploy the smart contract to the blockchain. And something else, in case that you don't know, when we deploy a smart contract in the blockchain, the contract cannot be changed, like never. The contract, if we deploy this code to the blockchain, then this will be the code that will be there forever. Except there are also some patterns that allows you to upgrade the smart contracts, but that's more advanced. I will say that you can learn that after you know Solidity, because that's not really like useful at this point. But yeah, then we have the state variables, the constructor, and the functions. For the functions, I will say that we have two main ones: reading functions and writing functions. So the reading functions are functions that will just allow you to fetch data from the blockchain just to read a value. So in this case, when we have our counter, the reading function will allow us to know what is the counter value currently. And then the writing function will allow us to actually increase the counter or change the counter. So the main difference is that for the reading functions, we don't need to have an account. We don't need to have a wallet. So anyone can interact with reading functions. But to interact with writing functions, you need to have a wallet and you need to have funds in that wallet, because you are writing something in the blockchain. When I say writing something in the blockchain, I mean like edit a value or deleting a value or something like that. So always to edit something in the blockchain, you will need the funds, because you are sending a transaction to edit a value, delete a value, or write a value. Yeah.
You mentioned that you cannot change the code once you do the blockchain, but I think the writing function actually change something in the code. So how is that?
Oh, good point. So writing functions will not change anything in the code. Will change the value of a state variable. Like for example, let's say let's just do this like with something like this. Let's say that we have a state variable that is called message, right? And then this state variable message will just store a message, a string, right? So a writing function can function to update the message. So this is a writing function that the only thing that we'll do, will update this message for, let's say, hello, right? But then after that, we call this function again, and then we upgrade the message to hi. So we are actually changing the state variable, but this function will never change. This function, the only thing that will do is to update the message. And you can never change the code of this function to update the message. So that's why they will change this code here, the state variable, but not the functions itself. And then the reading function, what will do? Function to read the message. So when you call this function first, it will return the value hello. And then when you call it again, it will just return the value hi, like after you update the message. And this is basically the structure. But then these two functions will always be like that. Like the implementation of the function cannot change. Yeah, good point. Any other questions so far? Okay, perfect. So let's continue with our counter contract. So our counter contract will have a state variable that will be a number, right? So in Solidity, the numbers are u into 56, and there are no negative numbers. So we can just put u into 56. That's like the unit that you always use, but you can do u into 64 or whatever, but let's just use 256. And then we will call it counter, because this contract will only have this state variable counter that will increase by 1. So in the constructor, what we are going to have is just to initialize the counter. So let's say the counter itself by default is 0, because the default value of uint or any number will be 0. So when we try to call this counter, in the beginning will be a 0, but then what I can do is that in the constructor, when I deploy the contract, I want to set the counter to 7, for example. So what we can do is just to write counter equal to 7. So what happens is that when we deploy the contract to the blockchain, the counter will start in 7 instead of 0. Any questions with the constructor? Clear? Yeah. It's supposed to be from 7? So I'm setting the starting point here at 7. So then when I call this function to increase counter by 1, then the next one will be 8. But I mean, if I don't do this, then the counter will be 0. I'm going to show you that here in Remix, so you will be able to understand a little bit more about this. But yeah, I'm going to, maybe in a few minutes, to answer that question way better. Any other questions so far? Great. So yeah, we are initializing the counter at 7. So when we call the contract, the counter is starting at 7. That's why I have the constructor here. Then we are going to write a reading function to just return the current value of the counter. So the functions in Solidity, you just need to type function, then the name of the function. I will call it getCounter. Then we open the parentheses. This is not accepting any parameters. And then the reading functions will have these keywords: external view returns. The view is because the function is only allowing you to view data in the contract, and returns is because it returns a value. And then we need to specify the value that is returning. In this case, it's returning a u into 56 because we are going to return the counter. And our counter is a u into 56 variable. So that's why here we need to type the u into 56. We put the curly braces. And then here we just put return counter because it's just returning this variable. Any question with this reading function so far? I hope you are not lost. I hope you are able to follow this. Are you able to follow? Okay. Perfect. So yeah, this function is only returning the counter that in the beginning will be a 7, right? So you will be able to see that in 1 minute. And then we need to create a writing function that will update the counter. Maybe we can increase the counter by 1. So the reading functions, we just need to type function, and then maybe increase counter, parentheses, and then we just put external. It doesn't have to be view returns because this is not returning anything. And then we just open the curly braces. And then we can get our counter plus plus. So we are increasing the counter plus 1 every time that we call this function. But if you want, let's say, to create another writing function to set the counter for a random number, what you can do is that instead of putting counter plus plus, then this function can receive a parameter that will be a uint256. Let's say new starting point. And then our counter can start in this new starting point. So this set counter is just to kind of set the counter to a new starting point, or this increase counter is just increasing the counter by 1. And these two functions are writing functions because are updating our state variable. If our functions are not updating our state variable, then they will be reading functions. Any question with these two writing functions so far? What, sorry? Oh, yeah, I noticed that when you have, okay, because there are two types of kind of variables that we will have here, the state variables that are here. Actually, one time when I was learning, I also saw that some people put s underscore and then the name of the variable, just because this means that this is a state variable. So if you have another thing, let's say string s underscore message. So that's something that I saw one time in some chain link tutorials, but I never used that. And then I saw the same with these values in the parameters of the functions to put an underscore here too. Yeah, you can put that just to make sure that the ones that don't have the underscore are state variables and the other ones are just values of the parameters that you are sending in the functions. Perfect. No more questions so far? Is everyone able to follow this? Okay. So now we wrote the smart contract. So we want to test this, right? We want to test that if when we deploy the contract, if this actually started in 7, and then if we call the increase counter, if this actually increased the counter by 1, and etc. So what we can do is first, you will need to come to Solidity compiler, and you will need to see this check here. If you don't see the check here, then you can click here in auto compile or in compile counter. Yeah, and then when you click here, you are just compiling the code to make sure that you don't have any errors, any typos or something. Is everyone able to have this green check here? Or is someone not getting that green check? Okay, so this makes sure that our contract is well written. So after we compile, then we come here to this one that says deploy and run transactions. And then here is where we are going to have fun, like testing the contract and deploying the contract. So here in the top, we will see this environment. By default, you will have Remix VM, Remix Virtual Machine. And this is just like a testnet environment that allows you to deploy the contract locally in this Remix environment and to test it. So for now, we are going to have the Remix VM. And then Remix also give you like 15 accounts for testing with 100 Ether. So I will just use the first one. That doesn't matter. Because remember that every time that we send a transaction, we need funds because we are spending funds. When we deploy the contract, we are sending a transaction, so we are spending funds, we are spending money. When we set the counter, when we increase the counter, we are also spending money. So that's why we need these testnet tokens. And then if you scroll down, we will see the name of our contract here. And then we can see this deploy button here. So if I click in deploy, I am deploying my contract. When you click in deploy, you will see this green check here because you deploy the contract. And then it is showing you the contract address here. Contract address here, but then this is just deployed locally. We are going to do this in a few minutes in the Ethereum testnet, and it will be the same. So this is locally where it's deployed, and then if we scroll down here, we see deployed contracts. And then we can see that my contract DeKUT is here. Then when I click in the arrow, we see the functions that we get. Get counter, set counter, and increase counter. So you can see that get counter, because it's a reading function, is blue. And then the writing functions are orange, because the writing functions will change the state variable. So right now, if I click in get counter, we can see that the value that is returning is a 7. Because in our constructor, we just hard code the counter to 7. Then if I click in increase counter, and we click again in get counter, we will get a 8, because now I just increased the counter, right? And then if I check this set counter, we can see that set counter accepts one parameter here, one argument that is a uint256. So I can just put 100, for example, and then I can click in transact to send the transaction. And you can see that every time that you send a transaction, you will get a green check. And then if I click in get counter again, our counter is at 100 now, because I just changed it to 100. Okay, so any questions so far with this testing the contract in Remix Virtual Machine? Yeah. On Remix. Only on Remix. To deploy it on the testnet, we will need to change the environment. Because right now the environment that we are using is Remix Virtual Machine, but you have a lot of different environments. The one that we are going to use is injected provider to deploy it on the testnet. But yeah, right now it's just Remix to make sure that the contract works. After we know that the contract is working properly, then we can deploy it on the testnet. Any questions so far? Okay, what I'm going to do is actually, okay, I'm going to show you something else. Instead of hard coding this to 7, we can also just send an argument in the constructor, and it can be a starting point. So instead of hard coding that, the person that will deploy this smart contract will be able to choose the starting point of the contract. uint256. So what I did is, instead of just hard coding the counter to 7, I will allow the person who deployed the contract to send the starting point instead of 0. Okay, something else to show you. If I don't set the starting point to nothing, we will get a 0 here. So I'm just commenting the constructor right now, and then I will just clear my deploy contract here in the left. So now there are no deploy contracts. And then if I click in deploy again, now we will have a new contract. Something important, every time that you update the code, you need to come here to the left and deploy the contract again. This is not like updating. So now that I just commented the constructor, I deploy the contract again, and then I click in get counter. We see that now is 0, and it didn't start in 7, as I hard coded here. Now I just remove the comment here. And now when I see the deploy is not working because it says input required. Because the constructor now is waiting for an input. That will be a starting point. So if I put 99 as a starting point, and then I click in deploy, we can see the contract here again, get counter, and then my starting point is 99. Okay. Is there someone lost with this? It's easy, it's hard. Should I add more complex things? Am I too fast? Everyone is on the same page? I don't have any issues to come back and explain something in the since the beginning. Yeah, are you good? Yeah. Wait. Let me go there. Perfect. Any other questions? No? Okay. The last thing that I want to do is I will actually remove this function of set counter. And then I will only have two functions, increase counter and decrease counter. So we are going to write function decrease counter external and then counter minus minus. So when we call the increase counter, it will increase the counter by 1, and when we call decrease the counter, it will decrease the counter. I will actually do something to encourage participation today. I will give, let's say, maybe I will ask some random questions during the workshop, and then the person that answered correctly, I will give them $5. And then I will give maybe $20, $30 today, just for you to get something today too. So I have a question here. You don't need to have the right answer, but I mean, you will get the $5 if you say the right answer. What happens if the counter is at 0 and we call the decrease counter? Who want to say that something?
I think there should be sort of like an error because when starting out with increasing the UI, you say it doesn't support synthetic numbers.
Okay, perfect. Yeah, that's correct. Maybe, Gideon, are you able to maybe have the names of the person that answered correctly? So at the end of the workshop, we can give the $5. So yeah, here's the first one. Sorry? This one? Yeah. Perfect, yeah, and then with some merge too. Okay, but then that's the right question. So if the counter is set to 0, and we call the decrease counter, remember that there are no negative numbers in Solidity, so it will just have an error. So right now, our contract, let me just go through the contract again. Our contract has this. The license, SPDX, license identifier MIT, the Solidity version 0.8.0, then the contract object, and then inside the contract we have the state variable that is just a uint256, a number counter. We have our constructor that is setting the counter to any starting point that we want. Then we have the reading function that is getCounter. This will only return the counter just for us to know what is the current number of the counter. And then we have these two functions, writing functions, increase counter by 1 and then decrease counter by 1 too. No questions with the smart contract? Okay, so if I click again in deploy, and then I set the counter to 0, when I click here in deploy and then I put this 0, I click deploy, then I scroll down to see our deployed contract. I click in get counter, we have a 0, and then if I click in decrease counter, we see that here we got an error. We have this X here instead of getting the check. The transaction was reverted. But this was, if I'm not mistaken, something that was only introduced in Solidity, in the version 4 of Solidity or something like that. Because if I try to do, let's try, I'm improvising with this, but if I try to change my smart contract to a version number 4, I don't know if this will work. And then what happened, this was when I was learning, I discovered that, when I was learning Solidity. Let me see something. I just want to show you something. View. Oh yeah, but what happened with Solidity, like 0.5, something like that, was if it was a 0, and you decrease the counter, it will actually go to the max value of the U in 256. So that was like a bug before, and then yeah, they upgrade that in the Solidity 0.8, I think. But that was like a big error that you have in Solidity before. So always try to use Solidity 0.8 or above versions, so you don't get this weird behavior. And yeah, I think now we can deploy the contract to the testnet. But yeah, I just want to make sure that the ones that are following are understanding so far the contract. We'll only have these three functions: get counter, increase, and decrease. And then we set the counter in the constructor. Yeah, no questions before we deploy the contract? Yeah? Oh, I don't really know. Why there are not negative numbers in Solidity? I don't really know the answer to that question, but that's a good question. But then what happened in Solidity is that they're not negative, but then there are like large numbers. But yeah, that's a good point. Why there are not negative numbers? I don't know. I don't have the answer to that one. That's a good one. Yeah, you also have a question? The which one? Yeah. That's basically the same. They are the same. The only difference, just for you to tell you, that's a little bit more advanced too. She's asking why I'm using external instead of public. So what happened is that there are different types of function identifiers. So okay, let's dive into that. That's why I like to improvise, so when people ask these questions, we are able to be flexible with the time and answers. So let's do something. I will create 4 functions, just for you to understand that. Function public, that will be public. They will be empty, but just for you to understand. Then function external. I'm putting a double L because it cannot have the keyword external, so just put it like that, external. Then function private. And function internal. Okay, so there are these 4 types of function identifiers. So public and external are basically the same. The only difference is that external will only allow this function to be called by other smart contracts or wallets from outside the smart contract. But public will be the same, will allow you to do that too, but public will also allow inside the smart contract to be able to call this function. So let's say if the internal function, I want to call the public function to do something, that will work, but then when I try to call the external, it will not work. So this is more about who is able to call these functions and who is not able to call the functions. That's the only difference of the identifiers. So public and external are really similar. External is more used because it's more efficient in gas. So external is more if you don't mind, if you are not calling this function inside the contract, just use external. And then external public can be called outside of the smart contract. Private and internal cannot be called outside of the smart contract. I'm going to deploy the contract here, and then you will see. Now you will see that we have external and public, right? But we don't have private and internal because these functions are not, we cannot call these functions from a wallet, right? But then we can call these two from a wallet or from another smart contract, but we cannot call these two from outside. So these 2 functions of private and internal can only be called inside this smart contract. Does that answer your question? But yeah, external is, in terms of gas, external is better than public. Yeah, normally I don't explain this. This is maybe a little bit more advanced, but yeah, for you to know, now you understand the difference of external, public, private, and internal. Any questions? Yeah? When you are writing the function, here you always need to put returns with the S, just to specify that the value that you are returning. But this is only the returns with the S is just the keyword for the view returns functions that are the reading functions. But then in the code itself, you need to write the return without the S. So these returns is only when you are writing the function name, the function identifier, is always with the S here. And then here, just return, and then the value that you are returning without the S. But yeah, we have those two keywords there too. Any other questions? Yeah? That's a good question. Why Solidity doesn't allow two constructors? I don't know what, in Cardano you can have two. Because I also don't know what, okay, well, I have a question for you. What can be the use of two constructors? The other constructor can be called. Yeah, that's a good question. Yeah, so Solidity only accepts one constructor, but then you can do whatever you want in that constructor too. But yeah, I also don't know the answer why they cannot allow you to have two constructors. But that's a good question too. Any other questions with the contract, with Remix? Okay, so now we are going to deploy the contract to the testnet. So to deploy the contract on testnet, we need to change this environment. Instead of Remix, we need to choose injected provider. In this case, I have MetaMask. Let me just double check something. Okay, so when I click here, environment, injected provider, MetaMask will pop up and will ask me to connect one account, one of my wallets. So as you can see here, it's asking me, hey, please connect one of your accounts, or I can connect all of the accounts if I want to. In this case, I will connect maybe these two, ETH, Oxford, and Legos. In one, I have 1.07 ETH, and in the other one, I have 4.95. Maybe I can connect this one too. This one, I have 349. So I'm connecting 3 accounts. Next, confirm. And then we can see that our environment is now Sepolia network. And then the accounts, we don't have 15 accounts, but instead I have the 3 accounts that I just connected with MetaMask. This one with 1 ETH, this one with 349 ETH, and this one with 4 ETH. Yeah, the 3 accounts that I connected. And another important thing, right now it's showing Sepolia here, because in my MetaMask, my current network is Sepolia. Here I can change my network. So if instead of Sepolia, I put, let's say, base mainnet, then I will deploy the contract to base. In this case, we are connected now to the chain 8453. In this case, this is the chain ID of base mainnet. Or if I change to Ethereum mainnet, it will show that the chain ID is 1. So I just change to Ethereum mainnet. And then here, we can see that we are connected to main. And then my accounts are in 0 because I don't have funds in the Ethereum mainnet. My funds are only in the Sepolia testnet. So yeah, just make sure that you are connected to Sepolia testnet or any testnet that you want. Something else, if you don't have testnet tokens, you can come to Google and then you can put Sepolia faucet, Google. And then you can see this Google Cloud, Ethereum Sepolia faucet. And then here you can select the network. In this case, it's Sepolia, and you can put your wallet address. And then they will send you testnet tokens. So I will put this one, copy paste, and then they will send you 0.05 Sepolia ETH. So yeah, in case that you don't have funds, you can go here, Google Cloud Web3, choose Sepolia, and then you will get tokens. Perfect. So yeah, this is how you can, instead of Remix Virtual Machine, we are changing to injected provider MetaMask, connecting one account, and then from this account is the account that I will deploy the contract. So I will choose this account that ends in 179, and then I have one ETH. So just make sure that I select that one. Then when I scroll down, I will set the starting point of my contract to 99. And now when I click in deploy, MetaMask will pop up to ask me to deploy the contract. So as you can see here, we have MetaMask, and then we have contract deployment. And then here we have the fee that we are paying to deploy this contract. Here is the total fee. I can just put this a little bit faster. You can choose the gas fees that you want to pay. If you choose low, like to pay low gas fees, then it will take 60 seconds. If you pay the market, that's like an average, will take 60 seconds. Or if I choose the gorilla one, the aggressive, it will take around 15 seconds to deploy my contract. Another question, who is able to explain to me why, if I choose aggressive, it will deploy the contract faster than low? Perfect. Yeah, that's true. Gideon, that's the other guy for the list, for the winning list. So what happened is that in the blockchain we have a bunch of, like, let's say validators, and they are always receiving a lot of transactions, right? But then for every block that is minted in Ethereum, that is only every 12 or 15 seconds, you can only have certain amount of transactions. You cannot have all the transactions in one block. So you only have certain space. The space is measured in gas, and we can only have 30 million of gas per block. So if, let's say, just to give you an example, let's say that we have a smart contract and we have a function that has like a huge logic, and then that costs 30 million gas. Like every function will have gas fees. So when you are, for example, when we are calling this decrease counter, let's say that that only costs 10 gas. So when we are calling this, we are paying like 10 of gas, right? But then if this function has a huge logic, the gas of calling that function will be higher. And if that costs 30 million, that means that in one block, you can only call that function and no one else can send more transactions. Because the size of a block is 30 million. I don't remember if it's 30 million Wei or G Wei. Like that's the, let's say, size block Ethereum. Wei. Oh, okay, it's actually 15 million gas. Yeah. So that means that every block, you can only have 15 million gas of transactions. But then if one transaction costs a lot of gas, you can only execute that transaction in one block. So that means that if you send a transaction now and it's not executed, then you have to wait 15 seconds for the next block until one of the validators pick your transaction and then they validate the transaction. So what happened is that there are a lot of validators, and then they are picking the transactions that they want. But then when you send higher gas fees, as he said, that means that you are sending like more tips. So of course the validator will pick your transaction first because you are paying more gas fees. So in this case, this aggressive is 0.1, 0.14, and then the low is 0.08. So of course, if I send the aggressive, they will pick my transaction first. So I will just choose aggressive, confirm. Remember that we are deploying this to Sepolia testnet. You can see here the network that you are connected, or also you can see the network here. Then when I click in confirm, we are going to wait here for the green check with the transaction. It says here pending, creation of the DeKUT pending. And then, meanwhile, we can go to the Sepolia Block Explorer. You can just type Sepolia Block Explorer. And then we can see this testnet Sepolia Blockchain Explorer. And then if I go to check my account, So I just copy paste the address, and then I put the address here of my account. We can see that 30 seconds ago, I sent a transaction. And that transaction was a contract creation. And this was the transaction fee that I pay for that. So if I click here in the contract creation, this is the contract that I just deployed. And then if I come back to Remix, we can see that here is the contract address. Let's see, that's the same. Oh, that's not the same, actually. I don't, okay, it's supposed to, Remix is supposed to show you here. It's still pending. I don't know why it's taking a while. But Remix is supposed to show you once this transaction is executed to show you the contract address. But yeah, it's just not loading here. But then if we go to Sepolia, you can see that I deployed the contract like 1 minute ago. Do you guys have any question with this so far? Just to go back before I just do more things. So remember that just to deploy the contract to testnet, I just changed it here from Remix virtual machine to injected provider. And then I connected MetaMask. No questions? Yeah? You were not able to get that? It's not reflecting? Okay, show me. Yeah, maybe that can take a while sometimes. Also, if you need testnet tokens, you can maybe send me your address later and then I can show you. Something important is, remember that there are like a ton of blockchains, a lot of networks, and you just need to make sure that you are connected here to Sepolia. Otherwise, right now my balance in Sepolia is 1 ETH, but then if I check in Ethereum mainnet, my balance will be 0, right? And then if I check base mainnet, my balance will be 0 as well, because I only have funds in that wallet in Sepolia. So that means that always make sure that you are connected to the network where you have the tokens. Any other questions? Okay, perfect. So as you can see, here is the contract deployed to this address. And then something really important that I always encourage people to do is to verify the contract. So to verify this contract, we can come here to contract. And you can see that there is no code. So by verifying a contract, what we are going to do is just to publish the code of the contract in the block explorer. So every time that someone interacts with our contract, they will see what is the code that they are interacting with. So never interact with non-verified contracts. So I just click there in verify and publish. Then we see this menu here with the contract address here. The Solidity compiler type. This is just a single file because we only have like one smart contract there. Then the compiler version, 0.8.0, because that was the compiler. Let's close this. The compiler that we set here, 0.8.0, and then the license is the MIT. The one that I also put here in line number 1. And then I click in continue. And then here, this will ask me for the code. So I will need to go to Remix again and copy paste the code. So I come here, I copy all of this, everything, then I paste that here. I just scroll down, I just copy pasted the code, scroll down, verify and publish. And perfect. And then successfully generated bytecode and ABI for this contract address. So now, as you can see, I come back to my contract, and then we have this green check here. And then we can see that the code of the contract is here. We can see the contract DeKUT, the class here, the state variable, the constructor with all the comments, the reading functions, the writing functions, etc. And then if we click in read contract, it will allow us to interact with the reading functions. So in this case, the get counter, and it's returning 99. And then if I click in write contract, it will allow us to interact with the writing functions too. So decrease counter and increase counter. But as you can see, if I try to click it, it doesn't work because you need to connect the wallet. So remember that to read contract, you don't need any wallet. You can see that I'm clicking in get counter and I get this 99. But then when I click in write contract, I need to connect the wallet. So I will need to click here in connect to Web3. MetaMask will pop up. Oh, I already have it connected. So let me just disconnect. So when you click in connect to Web3, MetaMask will pop up here, and then it will ask you to connect an account. So I will just connect this one, the first one, it Oxford. I will click in next, confirm, and now my wallet is connected. And then if I click in decrease counter, MetaMask will pop up. I will also choose aggressive gas fees to make it faster. Confirm. And then if I just go again to the address where I just deployed the contract and where I just sent the transaction, we will see that the transaction will be here. So 7 minutes ago, I deployed the contract. And a few seconds ago, I interacted with the contract. It will show here soon. And then the counter should be 98 because we decreased the contract by 1. If I come again to read contract, get counter, you can see that now we have 98. And then let's see if the transaction is already here. Okay, so 8 minutes ago, we have a contract deployment, and 30 seconds ago, we have an interaction with the function decrease counter. You can see here the name of the function. And then here, that's why it's important, the block explorer, because we're able to see what's happening in the blockchain. And then here we can see the get counter is 98. And then the same, if I just click in increase counter, then it will go to 99 or decrease to 97. Any question with this so far? Okay, now we don't have the time, we have to go for lunch. But then after lunch, what I want to do is to create a React app to interact with this smart contract. So maybe if you are not able to deploy this contract or something, I can help you during the lunch to make sure that you were able to deploy the contract. So when we create the app, we are able to interact with the contract that we deploy. Yeah, any questions so far? We should go for lunch now? Yeah? Yeah, then I think we can go for lunch. Recording again. So I just created the React app. When you create a React app, by default, you see this. Who is not really familiar with React? Everyone is familiar with React? Okay, that's good. Okay, so then in the React app, we are going only to change the app.js. So what I'm going to do is just to remove all these things, to not have any code here, to make it more clean. So this is what we have right now, just this logo rotating a little bit. So what we have to do, maybe I will, in the README, I'm going to put the steps. That will be easier, steps. The first one is npm install web3. So we are going to use web3.js. Web3.js is this JavaScript library that will allow you to interact with the smart contracts from the front end. npm install web3. Then initialize web3 object. What else? Import ABI of the contract. Initialize contract. Call the contract. Then 6. Connect accounts. Interact with writing functions. Okay, so this is what we are going to do. First, we are going to install web3. So npm install web3. npm I web3. And this is the step-by-step of the things that we need to do in our React app to be able to have something interacting with the contract. So I will just check the package.json. The web3 is installed here. Okay. It's there. Does anyone have any questions so far? I just created the React app. I cleaned the app.js code, so we don't have anything there. And then I just installed the web3 library, npm I web3. I will stop like step by step, so if someone gets lost, don't be shy. Okay. So after we install the web3, we need to import the web3 library. And import. So to import the web3 library, here in the top, we need to type import curly braces web3. This web3 with the W uppercase from web3. This is the web3 module library that we just installed. So we are just importing the web3 object with W uppercase from the web3 library. Let me add comments here too. I'm going to put this React app in GitHub as well. And also I will publish the video of the React app on Twitter later today. Import web3 module. Then the next step is to initialize the web3 object. Let me do that here. To initialize the web3 object, we just need to type const web3 equal to new web3. So we are initializing this object that we imported here, and we are storing that instance in this web3 variable, constant. Any questions so far? I'm going to show you what this is doing in 1 second. I'm going to maybe show you some extra things that you don't need to do, but just for you to understand what's going on here. Like, what is this new Web3 thing? So in this new Web3, we need to type window.ethereum, and then we are kind of connecting the React app to the injected provider. Injected provider will be the wallet that the user has in the front end. But when you don't have window.ethereum, you can also hard code like a blockchain network. So let me just do two things here. Initialize with RPC, and then initialize with, you don't need to do this. This is just a little extra for you to understand more with the injected provider. So if we initialize the Web3 object with the RPC endpoint, we need to hard code like a URL here. I'm going to show you that. So let's say that I want to interact with Ethereum mainnet. So here inside this new Web3, I will put a RPC that is connected to Ethereum mainnet. If I want to interact with Polygon, then RPC that is connected to Polygon. And then if you wonder what is an RPC, so we can go to chainlist.org, and then in chainlist.org you will find a lot of RPC endpoints. Let me show you something else here, Denver. This will allow you to understand what I'm talking about here too. Yeah, this one. So this is basically like a dApp communication flow. So we have our dApp. In this case, we have a React app, right? Then our React app will use Web3.js in the front end. And then the Web3.js object will connect to an RPC endpoint or an injected provider that can be MetaMask. And then the RPC endpoint is the one that will interact with the nodes. And then the nodes can be Ethereum, Avalanche, Polygon, any EVM network. So this is basically what we are doing right now. You can also use QuickNode, Infura, Alchemy, but I'm using these public RPC endpoints from Chainlist. So if I check Ethereum mainnet, and then an RPC endpoint is just a URL. So this one is a RPC endpoint to interact with Ethereum. So if I initialize my Web3 object with the RPC endpoint that is interacting with Ethereum, now I'm going to interact with Ethereum. But then if I change that to interact with RPC from Polygon, it will interact with Polygon. So I will show you how this works. I'm just going to console log. For us to see to which network we are connected, we can use this Web3 object here, web3.eth, and then .get chain ID. And just by doing this, we are going to see the chain ID that we are connected right now. This is await. So maybe I will need to function. Okay, I'm just doing this to show you the difference, but we don't need to do this in the final app. Chain ID. Okay, so when I click in this button, in the console we are going to see to the chain ID that we are connected. Right now, because I input Ethereum RPC endpoints, we are going to be connected to Ethereum, right? Then the chain ID of Ethereum is 1. So if I click here in get chain ID, we are getting a 1. Maybe let me put something here, chain ID. So we can see that the chain ID is a 1. And now, if I change my RPC endpoint for, let's say, Arbitrum, and then I click again in the button get chain ID, but now I changed the link, we can see that the chain ID is 42161, and this is the chain ID of Arbitrum, and so on. We can do the same with all the EVM networks, all these networks, Base, Avalanche, Polygon, etc., and then we'll be interacting with that network. Do you have any question with this part so far? This is important. So if you got lost here, let me know. Let me just recap again. What I did was first to import the Web3 module. Second, initialize the Web3 object. So this Web3 object, we type new Web3. And then we are passing here an RPC endpoint, which is just a string. I got that string from chainlist.org, where you can find a lot of RPC endpoints. And then I'm just using the Web3 instance here to get the chain ID that we are interacting with. Questions? Easy? Hard? Easy? Hard? If you are struggling something, I can go there and check. Like, do you need help? Do you want me to go there and check something? Yeah? Let me just pause this. Start this. Oh yeah, let me repeat that for the recording. So the only difference that I did right now was instead of initializing with a string for the RPC endpoint, we initialized the Web3 object with window.ethereum. You can see here line number 9 before, and now the after for the way that you create apps is with line number 12. new Web3 window.ethereum. And now if we try again this console log web3.it.getChainID, we will see what happened. So right now, if I open my MetaMask, you can see that I'm connected to Ethereum mainnet here, right? I just choose Ethereum mainnet. And then if I click in Get Chain ID, I'm getting the chain ID number 1. And then if I change my network of MetaMask to, let's say, Arbitrum, or maybe Base. So now I change to Base, and then if I click again in Get Chain ID, now it returns the chain ID of Base. Because now it's not connected to a hard-coded RPC endpoint, but it's connected to my MetaMask. So it's showing the chain ID that I'm connected from my MetaMask, or in this case, the user's network. Any question with this one so far? Yeah, the only thing is to initialize the Web3 object with window.ethereum. And then we are connecting the dApp to the user's MetaMask or any wallet that they have. Oh, sorry, I cannot hear you. Oh, no, that wasn't. That actually taking the Ethereum browser object of the user, so it can work in any. Yeah. Oh, that's perfect. Yeah, it works anywhere. Okay, so I will just delete these comments to clean a little bit the app. So yeah, that was only to show you the difference. So far we only import the Web3 module, we initialize the Web3 object with window.ethereum, and then the next step is to import the ABI of the contract, because we are going to interact with the contract. So where can we get this ABI of the contract? In the repo that I put here, DeKUT Workshop, you can go to Sepolia, to the Sepolia testnet. And remember that we deploy the contract, right? So when we deploy the contract and we verify the contract, you can see here the code of the contract that you deploy, right? Or in this case, you can also use the contract that I deploy in this URL. Remember that the URL is here in this README, so you can still use my contract. And when you scroll down, you will see this ABI. Gideon can explain us what is an ABI. A little bit louder, please. Thank you, Gideon. So we don't really need to know what is the ABI. We just basically need to copy-paste this object, right? This object, we will need it to initialize the contract that we are going to interact with. So every contract will have its own ABI. So now that you know where to get the ABI, also you can get the ABI from Remix. Here, when you compile the contract, you scroll down and you will see ABI here. So the ABI is the same because this was the same contract that I deployed, so it's the same ABI. Okay, now that we have this ABI, then we need to import this. I will just create like a file here, ABI. And then I will just put it here, const ABI. I literally just copy paste the ABI, I haven't done anything, then I will export default ABI. I put MJS instead of .js because I'm already used to use this export default and then import. But yeah, you can use .js and that will be the same. Now we need to initialize the contract. Here is where we are going to use the ABI. If you don't want to create a different file for the ABI, you can also just input the ABI here, like const ABI. But that's just like a little messy, but you can still do that. And you can see that I just put the ABI here, right? Maybe let's even use that so it's easier for you too. So for the contract, we need the ABI and the address of the contract. Now you have the ABI here, and then the address of the contract is also here on top. So const address. Okay, we will need these two things, address and ABI. Any questions so far with this? No? Okay, now you know the ABI, you can get it from Etherscan. The address is also there. You can use my contract that is deployed here. Remember that the ABI is here. Perfect. So now we have the ABI and the address. So what I'm going to do, let me just put this outside of this app. Yeah. To initialize the contract, we need to type. I will assert that in this constant. That will be my contract. And then we just need to type new web3.it.contract. As you can see, we're always using the web3.it object. And then when you open the parentheses in this contract, this will accept these two parameters, the ABI and the address. So in this line 19, we are initializing the contract that we are going to interact with the ABI and the address. Any question? Okay. So now that we initialize the contract, we can interact with the contract using this instance here. In this case, I call it my contract. So the next step after initializing the contract, we can interact with reading functions without initializing a wallet. So I'm going to show you right now. Right now, as you can see, I haven't connected any wallet to the app. But then when we are going to interact with the writing functions, we will need to ask the user to connect a wallet, to send a transaction and all these things, but that's after we first interact with reading functions. So interact with reading functions. Who can tell me what is the reading functions of this smart contract? The smart contract of the counter. Who can tell me what are the reading functions? Reading functions of the smart contract that we deploy. No, you cannot. You already. Don't remember that we have two functions, reading functions and writing functions. What are the reading functions? Yeah? Gideon, another one for the list. Yeah. You see him, perfect. So yeah, remember that the reading function, the only one is get counter. And that function, the only thing that it does is to return the value of the current counter. It's a reading function because remember that we are not changing, editing, deleting, modifying anything in the blockchain. We are just fetching data. That's why it's called reading, because we are just reading that data. So to interact with these functions, we don't need funds, we don't need wallets. And to interact with functions like that, we just need to type the contract instance, in this case my contract, dot methods, dot get counter, that's the function name, dot call. And let's say that you have other reading functions, so you will just need to change this name here. Let's say read function or do something. So it's always the same pattern. The contract instance dot methods dot the function name of the smart contract that we are interacting with dot call. Any question with this so far? If your function is not called getCounter and you put it a different name, so you need to put that name of the function. Because I call it getCounter, that's the function that I put here. Okay, and this is an asynchronous call, so we need to store this in a variable here. We need to add the await, and then we can just create a function that is called call contract. Any questions with this step number 4, interact with reading functions? Okay, now let's test this. So I will just console log the result. Current counter, result. And hopefully we are going to get 90, I think it's 97, if I'm not mistaken. And then this button, I will call it get current counter. And when you click in get current counter, you are going to call this function that is called call contract. And then this function is interacting with the contract here. So let's see what happened here. I click in get current counter. Okay, I have an error here. So the error that I'm having right now is saying parameter decoding error, returning values are not valid. Did you run out of gas? So something really important that you will never forget, I hope you never forget this error, because that happened to me a lot of times when I was learning, is remember that I'm connecting the app to window.ethereum. So that means that the app is connected to the MetaMask of the user. And then depending on the network that the user is connected, in this case I'm connected to Base, that means that my app is interacting with Base. But then the issue is that my contract is deployed on Sepolia. So my contract is on Sepolia and the user is connected in Base, so the user is trying to interact with a contract in Base that doesn't exist. My contract is in Sepolia. So that's why I'm getting this error. But then if I change my network to Sepolia, it should work. So that's why it's useful to have maybe like a little alert or something to ask the user like, hey, please connect to Sepolia. So then if I change to Sepolia, and then I try again to get current counter, we get the current counter is 98. Because now I'm in the right network, calling the right contract. And before we were calling this contract in Base, but that address doesn't exist. That contract doesn't exist there. Any questions so far with this? I can repeat whatever. I can go back since the beginning. Remember, let me just go over this again. Import the Web3 library. We initialize the Web3 with window.ethereum. Then after that, I'm initializing the contract in line number 19 by typing new web3.it.contract, and then we need the ABI and the address that I got from the Block Explorer. I'm storing this contract instance in my contract variable, and then we are using this my contract variable to interact with the contract just by typing my contract.methods.getCounter.call. Then what I'm going to do really quick is just, instead of console log, I will use the use state of React, just to put that in the front end. Counter, set counter. Who is not familiar with use state? So I can go over this again. Use state of React. Okay, we'll go. Counter. Okay, so this use state, it will allow us to, instead of printing this in the console, I want to create like a number in the front end that will update instead of printing in the console, right? So what happened is that we need to import this use state from React here, and then I just create a variable that is called counter. So to create a use state, we need to write this line. So const counter, and then set counter. So what happened with use state is to set this counter variable that you see here, we need to call this set counter. So in line 28, you can see that I'm calling set counter, and I'm setting the set counter with the result, which is the current counter. And then that will render in the front end in line 36 with the current counter here. So that's where I'm using the use state. This counter in line 36, and the set counter in line 28 to actually set the current counter. And then if I click in get current counter, oh yeah, we are getting an error here because this is returning a big int, and the React state should be a string. So result to string, and I guess it should work now. Yeah. So now every time that I click in get current counter, by default I have this none that I set here in line 16. But then when I click in the button, that will call the function, and then that will set the counter in line 29. So I click in get current counter, 98. So this is how we can interact with reading functions in smart contracts. Questions? Got lost? Too fast? Too fast? Are you lost? What do you don't understand? Where are you lost? Where? In line 19? Okay. So the first thing that we did was just to initialize the Web3 object here, right? But the most important maybe is in line 22, where we are initializing the contract. Were you able to get the ABI and the address? Okay, so then you have this here too. Yeah? Okay, so if you have the address and the ABI, do you have this line 22 there too? The ABI for? What is the ABI for? Gideon, what is the ABI for? Gideon is the ABI guy. What is the ABI for? Perfect. And to be honest, you don't even need to know what the ABI is for. You just need to copy paste that here. That's the reality. Like the ABI is just this object that is telling JavaScript, telling Web3.js, the functions of your smart contract. So when you check this ABI, you can see that this has decrease counter, get counter, and increase counter. So it's just decoding the functions that we have in the contract. But you don't even need to understand how this works, just to know, copy paste the ABI, because we are using the ABI to initialize the contract. Because Web3.js needs the ABI to be able to interact, to be able to know that that contract has these functions: decrease counter, get counter, and increase counter. Perfect. So yeah, in this line we initialize the contract, new web3.it.contract. We pass the ABI and the address. And then in line 26, we call the contract. So my contract instance dot methods dot get counter dot call. So if we look at this, actually it's just like 6 lines of code. This one and these ones, yeah, like the ones with the steps. Any questions? I'm really happy to just repeat this again. I don't have any issues with that. If you are lost. No? Should I continue? Yeah? Okay. Let's continue, because now it's getting more interesting, because now we are going to interact with writing functions. Who can tell me what are the writing functions of the contract? Who can tell me what are the writing functions of the contract? No one? You don't remember? Yeah? Set counter. Yeah, that's true. In this case, remember that I removed the set counter, so I only have increase counter and decrease counter. But yeah, before we have set counter too. So yeah, remember that in this case, the writing functions are decrease counter and increase counter. So we are going to interact with these functions now. Now we know how to interact with the get counter, but we want to interact with the writing functions, which is a little bit more complicated. Because we need to ask the user to connect the wallet so he can send the transaction to interact with that contract. So the first thing that we need to do in the steps that I have here is connect the accounts. So we need to ask the user, hey user, connect your account. Connect accounts. So I will just create a function that can be maybe increase counter here. Increase counter. And then one that is decrease counter. Okay, so I just created these 2 functions. I'm going to create 2 buttons to interact with these functions too. Increase counter. Decrease counter. Okay, so what I did so far was to create these 2 new buttons, increase counter and decrease counter. Each button will be connected to these 2 functions that are empty right now. Any question with this so far? Let's check the front end. Now we have these two buttons. Get current counter, increase counter, decrease counter. Where? Oh yeah. Okay, let me check your code. I'm just going to push this to GitHub now.
So guys, for anyone who would be left behind, you are putting together the gap. He is pushing the changes.
Yeah.
You can see them there. You can load the record and then you move on together from there. Start up. Yeah. There is the repository.
Yeah.
Just go to GitHub, search and record and then you see the repository there. So kindly you can do that fast and then we move on to that.
I will start this in accounts connected. So yeah, I just type web3.eth.request accounts. MetaMask will pop up. The user will choose which accounts he wants to connect. And then this will be stored in an array with the addresses that the user connected. So I'm just going to print this in the console to show you. Accounts connected. So I have this only in the button increase counter. Just connect. Okay, so if I click in increase counter, you can see that MetaMask is popping up, or Brave Wallet, the wallet that you have, and that is asking me to connect an account. If I connect these accounts, let's say DeKUT and Vault, then I click in next, confirm. You can see that in the console, we have the two accounts that I just connected. Any questions with this one? It's basically just line 34. Web3.eth.request accounts. MetaMask is popping up. The user is connecting the accounts, and we are storing that in this array of accounts connected. Perfect. And then if I try to click again, it's just showing the accounts that I already connected. And if you want to disconnect the accounts, you can click on MetaMask. And then here in the right, you can see the accounts that you connected. And you can disconnect all of them. Disconnect accounts. So the user is disconnecting the accounts from my app. And now the increase counter, click again, and then it will ask me again to connect an account. Perfect. So that's basically how we can connect the accounts. So after we connect the accounts, we can interact with the contract writing functions. So it will be similar to the call. So the contract instance, my contract dot methods dot increase counter, and then instead of dot call, we need to type dot send. So let me just put this as a reference. Okay, so I just put this as a reference. This is how we do call reading functions, and this is how we call writing functions. But then in this .send, we need to specify the account that is sending the transaction. So in this send, we need to open curly braces, and then we need to say from, and then the account that is sending the transaction will be this accounts connected from the user, accounts connected, in the slot 0. Because remember that this is an array with addresses, so we are just saying that the first address that is connected is sending the account. Look at the reading functions in line 37. We are not specifying any account because we are just reading data. But then in line 40, we are specifying who is sending the transaction to increase the counter. Any question with this one? If you are able to get these two concepts of interacting with reading functions and writing functions, you can create apps, because basically smart contracts only have these two types of functions, reading functions and writing functions. So yeah, I will just remove this. So remember, first we just connect the accounts. We store that in this array, and then here we are interacting with the contract. We put await, and this transaction will return a transaction receipt. We don't really need that receipt, but I will just print it in the console for you to be able to see once the transaction is sent. And maybe after the transaction is sent, I can just I can just call this function of call contract, maybe to update the front end. So call contract. Okay, any question with this function? I can just go over this again. Connecting the accounts, increasing the counter here, and then I'm calling again the get counter just to update the front end. So let's see if this works. So I will click in get current counter, and it's 98. So now I will click in increase counter. MetaMask will pop up, will ask me to connect an account. I will connect maybe this Legos account. Next, confirm. Then MetaMask will pop up again to ask me like, hey, you are going to interact with the function increase counter. You can see here. And then this is the gas fee. I'm going to put it aggressive. Actually, let's leave it like this. Confirm. Then here we will see the transaction receipt in the console, and then the counter will update to 99. Yeah, so now the counter is 99, and then here is the transaction receipt. You can see different information about this transaction. Then if I click again in increase counter, now MetaMask will pop up again to send the transaction to interact with the function increase counter. Confirm, and now the counter will be 100. Yeah, let's just wait. Oh yeah, 100. So now it's working. This increase counter? Oh, the call contract, yeah. Let's actually call it get counter. Yeah, get counter. So yeah, the get counter function is just interacting with reading functions. Any question with this? I'm happy to repeat. Let me actually push this to GitHub as well. Remember that this increase counter should be the function that you are calling. If you are calling the set counter, so instead of increase counter, you put set counter. And then if the function receives parameters, so then you put the parameters in this parenthesis that is here. So this was the function to increase counter. Now I'm going to do the same for decrease counter. Instead of copy paste everything, I will just write everything from scratch, but it will be the same. You just need to change this name, the name of the function here. So first thing is that we need to connect the accounts by typing web3.it.requestAccounts. Then I'm storing the accounts that the user connects in this array, connected accounts. And then we are interacting with the contract by typing my contract.methods.decreaseCounter.send. Then we open the object here to specify who is sending the transaction. In this case, the connected accounts in the slot 0, which is the first address that the user connected. Then in that line 48, that's MetaMask will pop up again to ask the user, like, hey user, you are interacting with this decrease counter function. Then we can store this in the transaction receipt. Then we can print the transaction receipt object. And we can just call the getCounter function again to render the front end with the new counter. So if I click in decrease counter now, MetaMask will pop up, and then it will tell me you are doing a contract interaction. That is not showing me the name of the contract function. Confirm. And now the counter is 99, and so on. And yeah, that's basically how you can interact with the smart contracts, reading function, writing functions. I will just push this to GitHub again. Yeah, the code is not that long, like 60 lines of code, but everything a little messy there. Yeah, okay, so I think now I'm open to questions, to repeat things, because yeah, I think this is working. At least we are able to go slow, so everyone is able, or most of you are able to follow. But yeah, I think that's kind of everything. Let me know if you have any questions. Open to questions. Or if you are struggling or something, let me know. I just pushed the code, so the code is there already. Yeah. So basically, if you want to interact with another contract, the only thing that you need to change is the ABI and the address, because that will be a different contract address, a different ABI, and then changing the name of the methods that you are interacting with. But yeah, this looks like it's working. So no questions, everything is clear. The last thing that I'm going to do is, okay, now I have this app in my local host. But as I told you, something that I did was to deploy this on Fleek. That's what I'm going to show you now. So you can build portfolio, and then you will be able to show this to the recruiters or something. This was exactly what I did like 2 years ago when I was learning. Then I deployed my dApps on Fleek, and then in my interviews I was sharing my screen or sharing the links. And actually on my LinkedIn I have these links somewhere there. So when you go to fleek.xys, you create an account, and then you will click and deploy your site. This is really easy. You just need to connect your GitHub account. So you click here on GitHub. Then you need to give permissions to Fleek to be able to access to that repo. So I will give permissions to access to the DeKUT Workshop. Okay, and something else before I forget this is in the package.json of your React app, you need to specify the home page. You need to put a dot. This is really important for the Fleek thing. So I'm just going to put home page dot, then I'm going to push this to GitHub again. And now in Fleek, I'm going to choose the repo, DeKUT Workshop. I will just click on deploy. This will read that it's a React app. Then just deploy site. Sorry. Then it will deploy, and then in around 5 minutes, I think, we are going to get a URL where you will be able to access to this dApp and interact with the dApp. So if I send this link to you, you can interact with my counter contract. So let's wait a few minutes. Also, something else, just for you to have a little extra bonus, this will also deploy to IPFS. Who don't know what is IPFS? Oh, okay. So IPFS is Interplanetary File System, and this is something like a blockchain of computers, a network of computers that are storing things. So in this case, they are storing your website as well. So this will give you a URL in IPFS. I'm going to show you that in a few minutes. And this URL will be there forever as well. So the front end of your dApp will be there. It's decentralized because it's a network of computers. Anyone can host a node of IPFS. And then in this way, you will have a fully decentralized app because the smart contract is in Ethereum, or Sepolia in this case, which is a decentralized blockchain. And then the front end will be in IPFS, which is also a decentralized network. And then everything is decentralized front end, decentralized smart contracts, which is like the back end. And then you have a fully decentralized app that no one can take off. Because if you have your dApp in a server, something like Vercel, for example, if Vercel breaks or whatever, then your front end will disappear. But then if you deploy your front end to IPFS, that will be there forever. And then you will have your fully decentralized app. But yeah, this can take a few minutes. And then we will see, instead of localhost, we will see a URL, a Fleek URL. And yeah, I think that's kind of everything. I'm going to stop the recording now.